Hello Year 12 and welcome to our 10th video here on our series on finance and loans. Today I want to introduce what is perhaps a new concept, and that of an annuity. We can understand an annuity as being like a savings account where I make regular contributions. So unlike compound interest, where we begin with some present value, some principal, we deposit that in an account and leave it there to accumulate interest until at some stage in the future we arrive at the future value. With an annuity, we put some money in at the beginning and we keep putting, we're going to say the same amount in, we keep making the same contribution every period until we arrive at some stage at the future with some future value. So the big difference between compound interest and an annuity is with an annuity we make regular contributions. We keep putting more money into that account. It doesn't just grow by the interest calculations, it also grows through contributions. Now the future value of an annuity, the same as the future value of compound interest, right, is how much money will be at that account at some stage in the future. Okay, that's fine. The present value of an annuity is somewhat more complex than that though, and it's worth paying close attention here. The present value of an annuity is that amount of money I would have to deposit into an account at the beginning and leave there with no further contributions to arrive at the same future value. So while an annuity requires regular contributions, the present value of an annuity considers what equivalent amount I could deposit and leave, right, with no more contributions. So of course, we would expect in nearly every case, the present value of an annuity is going to be quite a lot more than a single contribution. Now all of this might sound a bit complex, and to some extent it is. We're not going to examine and calculate these values from scratch. We're going to use, in most instances, some sort of table to help us perform those calculations. And I think it's worth jumping straight into that now and seeing how that might work. I should point out that not all of these tables are set out the same way. It's very important to read the headings and any other information around these tables. It's important that we know whether we're dealing with an annuity or compound interest, right, purely savings, and whether we're talking about future value or whether we're talking about present value. Now this table we can see here, it says this is the future value of $1 per period, and I think it says, well, it should have a heading above that saying that this describes the future value of an annuity. A little bit of common sense if we have a look at this. Let's say that, right, ignoring the interest rate, this says the future value of $1. So that means that if I put $1 in per period, now that might be per month, might be per quarter, might be per year, who knows? That doesn't matter in this case. That if I put in $1 per period, right, if I have done that, let's say 14 times, right, then I've put in $14. And you can see down here, right, if we go to the bottom of the 1% column, that there's the $14 that I've contributed, right? I've made 14 $1 contributions, and this part here at the end, that represents how much interest that's earned. Now that's a fairly complex calculation because $1 has been in there for 13 or 14 years, and the last dollar has only been in there, has only just gone in there now. You can see here that 2% out of that $15.97, $14 of that is what I've put in myself, and $1.97 is the interest. Okay, so that can be a handy sort of common sense check when you are looking at these tables. Right? You can see, well, if I've made 6 contributions, then I've put in $6. Right? The future value after 6 contributions has to be more than 6 times the contribution, right? Because I've put that money in myself, that hasn't gone down, it's earned some interest. Now, back to this table and to the example in question 19. We're going to use the table to find the future value of an annuity into which $1,500 is deposited at the end of each year, 7% per annum. Now, my contribution is $1,500. This table describes what happens if I'm putting $1 in. So I'm going to find a matching value here in the table and multiply it by 1,500. Okay, because we're putting 1,500 in each year, not $1. So we need to find 7% per annum. Again, we have to be careful to make sure that that rate there, right, per annum matches the time frame we're using for our calculation. So 9 years, 7% per annum. We're dealing in years consistently. That's good. So I look at my table. Whoops, I'll scroll down a little. I look at the 7% column here, right? There's my 7% column and 9 periods. So where the 7 and the 9 intersect, I get this value here. That tells me that if I'd put $1 in every year, then at the end of 9 years, I'd have $11.98, thereabouts. Of course, we haven't done that. We have put in $1,500. So the future value, that's what we're going to calculate. My future value is going to equal that number that we found there in the table, 11.9780. We multiply that by the size of the contribution, and that's going to be the future value of that annuity. If we pull up the calculator, here's my calculator, turn it on, get that out of the road there. So 11.978 times 1,500 equals $17,967. Okay, so that's using a table to calculate the future value of an annuity. There are more of these. We're going to use the same table to calculate the future value of these. So $400 every 6 months for 4 years, 14% per annum. Now, you can see now, with interest compounded 6 monthly, that I do have to make some adjustments. 14% per annum means 7% every 6 months. And it's compounding every 6 months. So we're actually going to be dealing with 7%. And 4 years, well, how many lots of 6 months is actually 8 periods? Right, we're going to make 8 contributions at 7% per annum. So this is in fact fairly similar to the last value. Here's my 8 and my 7%, right? If we can see that here, 7% per period, 8 periods, 8 contributions. This time, that is the factor that I'm going to use. I'm going to multiply my contribution of $400 by 10.2598. The future value is 10.2598, $400. And you can see there that annuity has a future value of $4,103.92. Now, $600, that's my contribution, every 3 months for 2 years, 12% per annum, compounded quarterly. With these questions, I should point out the compounding frequency is always going to be the same as the contribution frequency. Right? We're calculating it, other than that is beyond the scope of this course. So, nonetheless, I need to convert everything to quarterly figures. So, my 2 years becomes 8 quarters. And my 12% per annum, right, becomes 3% per quarter. Okay, so now we need to look down the 3% column to the 8 contributions. Right, so back to my table, 3% column, right, that's down here. 8 contributions, that's over here. We find the intersection of those, this cell here, And really, you want to be using a highlighter or drawing on the table or something here. It's not good with your textbook, but in any sort of assessment, any sort of exam situation, you definitely want to be highlighting, circling, some way indicating what you've done there. There's my 3%, there's my 8 contributions, and I get 8.8923. So we've got 600. My future value equals 8.89, was it 63? 8923, apologies, 23 times the 600, right, and that's going to be equal to, I don't like stringing my equals together, but okay, so that gives us a future value of $5,335.38. And finally here, $100 invested every month for 5 years at 10% per annum, interest compounded 6 monthly. Now, while I had suggested just a moment ago that the contribution frequency will always be the same as the compounding frequency, well, that's generally the case. I'm going to have to eat my words here a little bit. We've got an example where my contribution frequency is different. But what we're going to do is, right, we're going to investigate this. If I put $100 every month into an account for 5 years, 10% per annum, and the interest is compounded 6 monthly, then essentially, whether I put $1 in every month, $100 every month, or $600 every 6 months, because the interest is not being calculated in between, right, those two situations would be the same. So as with compound interest, when we were dealing with that, the compounding frequency is the one thing we can't really change. So I'm going to change here my $100 per month, right? I'm going to say that's the same as, oops, right here. Oh, my pen's gone funny. I'm going to say that's the equivalent to $600 per half year. Okay. Now 5 years means I've got 10 half years. 10% per annum is going to be 5% per half year. Okay. So using those figures now of contributions of $600, we're looking for the 5% column and the 10 contribution or 10 period row to get our factor here. So there's my 10, I go across. My 5 comes down here. So the intersection of that row and column is 12.5779. 12.5779. Times my $600. Okay, and you can see there that we have $7,546.74 as the future value of that investment. If I'm putting $100 in every month for 5 years, well, consider this. $100 every month for 5 years means that I will be putting in $1,200 a year. 1,200 by 5 would be $6,000. Okay, and you can see the interest there is $1,546.74. Similar to that rough calculation we've just done off the top of our head here, and in addition to what I've written down here in the notes, coming back to that idea of present value. In this example here, the present value of this annuity is not $100 that we put in, right, each month. It's not $600 every 6 months. It's what would I put into an account at 10% per annum, compounding 6 monthly, that I could leave there for 5 years, such that I'll end up with a future value of $7,546.74. Now, the way that we will solve that problem is, right, is that we will say that this, right, is our future value and use our compound interest formula. This is my future value. I know the rate of interest here is going to be 5% per half year. My number of terms is going to be 10, right? I substitute these values into our compound interest formula, and we use the compound interest formula to calculate a present value that will match this. We'll work through that in the exercise. That's above and beyond what we're mostly doing with these, certainly that we've looked at now. And I think this video has gone on for quite long enough already. Now, this is a complex, right, a complex idea that we've been dealing with today. If you're unsure of how this works at this stage, of how to do any of these things or what any of these things mean, please jot them down so you don't forget and ask those questions in class. Righto, thanks very much.